Okay, in this question, we're looking at two cards being drawn without replacement, so we won't put the first one back before we draw the second one from a standard deck of cards. And we want the probability of choosing a jack on our first draw, and then on the second draw, getting a queen. So if you think about the chance of getting a jack on that first draw, we would have 4 jacks out of 52 cards. So the probability would be 4 divided by 52. When we move to the second draw, however, we still have 4 queens we could get, so it's similar to the first draw. The difference is because one of the jacks is now sitting in our hand, there's only 51 cards to choose from. One of those 52 cards has been removed as an option, so our chance of getting a queen is actually a little bit better on that second draw. It's 4 out of 51, 4 divided by 51. So in terms of the calculation there, we would start off by saying 4 divided by 52. That's the chance of getting the jack on the first draw. Scoot this over. And then we would multiply that by the chance of getting a queen on the second draw. And there's 4 queens remaining out of the 51 cards there. And that would give us this answer right here. We're saying rounded to 4 decimal places, so that would be 0.0060. It would be the final answer there. The 3 would not be enough to round that up. So one question you might have is, how did we know to multiply these two together? Well, what we're using here is the multiplication rule for dependent events. And the reason they're dependent here is that the probability of just drawing a queen would be 4 out of 52. But that's not what we're dealing with here in step 2, because there's already some event that's occurred that impacts the probability of drawing a queen. And that particular event that occurred was that we already drew a jack, which has reduced the number of possible cards that we could get here on this second draw.